Good day, everyone. My name is Muhammad Farid from the University College of Agroscience, Malaysia. Together with my co-authors from UCAM, UKM, Orion Bioscience, and the Department of Environment, I'll be presenting our study titled Assessing the Impact of Pig Farm Effluent on the Water Quality of Sungai Tuang using Chemometric and Trend Analyses. Across the world, livestock farming is one of the hidden giants of water pollution. Here in Malaysia, Sungai Tuang in Malacca may be a small river, but it plays a big role. It flows past farms, villages, and down to recreational beaches. Yet, reports show worrying signs of pollution. What is missing is clear, scientific evidence that directly links pig farm effluent to this river's decline. That's the gap we aimed to fill. Our objectives were simple. First, to measure the real impact of pig farm effluent on Sungai Tuang. Second, to classify water quality using Malaysia's Water Quality Index. And third, to uncover long-term trends with chemometric and statistical analysis. Our study focused on Paya Mengkuang, Melaka, home to intensive pig farming. We sampled 7 points, 4 along the river and 3 at effluent outlets. Sampling was done in September and December, capturing 2 different seasonal conditions. For material and methods, we measured the key indicators of river health: pH, dissolved oxygen, BOD, COD, suspended solids, ammoniacal nitrogen, and E. coli, all using standard methods supported by DOE guidelines. For statistical analysis, we applied Welsh ANOVA and Games-Howell for differences, Water Quality Index for classification, and the main candle test for long-term trends. In short, we combined both short-term field data and long-term monitoring data to get the full picture. Let us look at the critical parameters. COD at L02 was sky high, over 1,400 milligrams per liter in September. Dissolved oxygen collapsed to less than 1 milligram, and E. coli counts exploded, more than 400,000 per 100 milliliters. These aren't just statistics, they represent a river struggling to breathe. So, how does this translate into the bigger picture? The Water Quality Index, based on Department of Environment's National Classification System, pulls all parameters together. In September, the upstream site S01 looked healthy, class 2 water, but downstream quality dropped into class 3. At the effluent sites, especially LO02, it plunged to class 4, polluted. In December, the same pattern repeated. The message is clear: effluent discharge is dragging the river down. When we look at the DOE's long-term data, the picture became even clearer. Dissolved oxygen is steadily falling. COD and E. coli are climbing year after year, and the water quality index is sliding from class 2 towards class 3. This is not one-time event. It is a worsening trend, confirmed statistically using the man-candle test, which is widely applied in hydrology. So, what does this mean? Pig farm effluent is the dominant driver of pollution in Sungai Tuang. It threatens fish, aquatic ecosystems, and local biodiversity. It poses health risks to communities and beach users downstream, and it shows that current treatment systems at farms are simply not enough. Our our findings echo other studies. Ling et al. 2014 reported similar impacts in Sarawak. Mofokeng et al. 2016 described severe oxygen depletion from peak effluent, and Abia et al. 2015 highlighted E. coli as a reliable indicator of fecal contamination in rivers. To conclude, our evidence shows that pig farm effluent is degrading Sungai Tuang's water quality. This is confirmed by both short-term sampling and long-term monitoring. Without intervention, the river risks slipping further from class 3 into class 4. But with stronger treatment, enforcement, and monitoring, recovery is possible. Therefore, based on these findings, we recommend three key actions. 1. Upgrade effluent treatment systems with longer retention times and proper design. 2. Strengthen cross-agency enforcement so guidelines turn into real action. And 3. Establish continuous monitoring using chemometric and trend tools to track progress over time. Together, these steps can restore the river. We thank Department of Environment Malaysia, the Department of Veterinary Services Melaka, Universiti Kebangsaan Malaysia, and UCAM for their support. Thank you very much for your attention. If you would like to discuss or collaborate further, here's my contact. I look forward to your questions and ideas. Thanks.